Good morning, students. I welcome you to the Greater Chennai Corporation online physics class today. We are going to see in electrostatics the dipole, electric dipole and its properties. What is electric dipole? Dipole. Di means two. Pole means opposite charges. Opposite charges. So, if you consider the two opposite charges, that system is known as the electric dipole. Suppose if the negative charge is taken, then if a positive charge is taken, these two charges are separated by some distance from center to center here. The distance is 2a. Why 2a? Because we have to measure the distance only from the center point O. From this point to this charge, that is positive charge, the distance is a. From negative charge to this distance is a. So total distance is 2a. So this charge is minus q, this charge is plus q. They are equal and opposite magnitude are equal, but the opposite charges, they are separated by a distance of 2a. This system is known as dipole. Normally, in and around us, most of the molecules are dipole in nature. The very best example is the water, H2O. Say, NH3, ammonia, etc. Water is the dipole. Say how? Suppose, let us consider this is the oxygen. Oxygen is minus. There are two H. This is hydrogen. This is also hydrogen. The hydrogen is positive. So, this is the water molecule. The negative charge and positive charges are permanently separated. So, you can call this as a dipole. See, the center of the two positive charges will lie exactly at this point. See. So, the negative charge and the positive charge, they are separated by a finite distance. This is a center, negative charge, positive charge separated by a finite distance. So, it is called the dipole. Okay. The next, we are going to see the dipole moment. The dipole moment is represented by the symbol P vector. Okay. So, now you consider this. This is a charge minus, this is a charge plus dipole, this is x-axis, say this is x-axis, this is y-axis, this is y-axis, this is the origin, you can say this is minus q, this is plus q, the equal magnitude. Let us take this distance is a, this distance is also a. This is the dipole system. Now we are going to find the dipole moment. Moment means what? Moment means you have to multiply by the distance. If you take this, if you take this system, the dipole moment P is a combination of the moment due to this positive charge and the moment due to the negative charge. The moment due to the positive charge is Q into R plus. Then moment due to this charge, minus charge, is minus Q into R minus. What is this? R plus and R minus. See, R plus is known as the position vector. The R plus is the position vector of plus charge from the origin. r minus is the position vector of the charge minus q from the origin. Okay. So r plus r minus. This is a position vector. So how to find the position vector? We know magnitude, the magnitude, otherwise known as distance, into the direction. So what is the direction? It is positive x. So a into, you can say, I cap. What is this I cap? I cap represents the direction in the positive x axis. Then minus q or minus, position vector of this minus charge. So magnitude also a, this direction is minus I cap. Why minus I cap? It is in the negative x direction minus I. This minus and this minus becomes minus into minus plus. So q into a I cap plus q into a I cap. So 2 times. So this can be written as 2qa into I cap. So this is the formula for what? The dipole moment. 2q. 2qa is called the magnitude. I cap represents the direction. I cap is what? The direction along the positive x direction. From this it is clearly seen the dipole moment is acting always towards right or the positive x direction. That means the dipole moment vector is acting from minus charge to plus charge, negative charge to the positive charge. So the magnitude of the charge, magnitude of the charge can be written as, omit the direction, so q into 2a, that's all, or 2aq, 2qa, whatever it may be. So this is the magnitude. Now we can say the definition of dipole moment. So what is this? We are multiplying the two quantities. What is the first quantity? Charge. What is the second one? The distance between the two charges. So now you can say dipole moment is the product of the any one of the charge, because since the two charges are equal, any one of the charge and the distance between them. So dipole moment is defined as product of any one of the charge and the distance between them. That's all. So this is the definition of dipole moment. This is the symbol of dipole moment, p vector. Okay. So what is the unit? Next is unit. What is the unit of dipole? See, on saying the formula, you can say the unit. Unit of formula for dipole moment is q into 2a. The unit of q, that is charge, is coulomb. 2a is nothing but the distance between. So distance unit is meter. So it is coulomb meter. The unit of dipole moment is coulomb meter. Okay. So the dipole moment unit is. See, in this case, we have taken the opposite charges, the dipole along the x-axis. Even when we take the dipole along the y-axis, like this, negative charge here, positive charge here, or in the z-axis, negative and positive. So in all the cases, the direction of dipole moment always from the negative charge to the positive charge. It is directed from the negative charge to the positive charge. Okay. See, in this case, we have assumed the opposite charges. Suppose if you take a single charge or two positive charges, the system of charges consisting of two positive charges or two negative charges. If you find the dipole moments, for these cases, always the dipole, we can also able to find the dipole moment for all the three cases. Suppose if the system of charges are there, then in this case dipole moment can be written as for system of charges, for system of or collection of charges, say dipole moment can be written as, what is the formula? This one, either you can say 2qa, the distance into charge, or this position vector into charge. So qi or I, okay. So it's a summation, I equal to 1 to n. For collection of charges, we can also find the dipole moment. So the dipole moment for the system collection of charges, P vector equal to sigma I equal to 1 to n qi or I. So the distance. Students, now we are going to see the problems involved in the dipole moment. The question is, find the dipole moment for the following configuration, charge configurations. So the first, let me take the first problem. Here in this case, two positive charges are kept at a distance. The distance is total 2a, that is from the origin, this positive charge is at distance a, this positive charge is at a distance a. What is the dipole moment for value of this configuration? Say dipole moment formula is 2qa or the charge into position vector. We have to multiply the charge and the position vector of each and every charges. How many charges are there? 2 charges. So this is R, Q into R1 or R plus. This charge is plus Q into R plus. So 2 charges are having the equal magnitude. The position vector is mentioned. So now Q into position vector can be written as A into I cap. For this positive charge, A into I cap. For this positive charge, A into plus Q into A into minus I cap. Now the value becomes Q into A I cap minus Q into A I cap. So both will be cancelling. What we are getting is dipole moment is 0. In this case, the dipole moment for the two positive charges becomes 0. So Q into R plus. What is R plus? R plus is the position vector of first charge, this charge. Here the R plus is the position vector of this second charge. Okay. If you substitute the magnitude and direction, both are cancelling. So now what we are getting is dipole moment is 0. First problem is over. Now let us come to the second problem. Say in this second problem, again two positive charges are there, but instead of at this distance, in the negative axis, the charge is kept at the origin itself. This is the origin. Origin itself. Now in this case, what is the dipole moment for these configurations? So dipole moment formula notation is P vector. Now since this charge is placed at the origin, so distance from the origin, the charge itself in the origin, so the position vector is 0. R plus becomes, for this case, R plus becomes 0. So the dipole moment, the moment of this charge becomes 0. So 0 plus the second charge into the distance R plus. Now A into, instead of R plus, you can write magnitude into the direction. So what is the magnitude? The distance is the magnitude, the direction is positive x axis. Now the dipole moment value is Q into I cap. See these two cases. Here also two positive charge, here also two positive charge. Here we are getting the dipole moment value is 0. But in this case, the dipole, it has certain dipole moment value. Why? Because we have shifted this charge to the origin itself. when it is shifted from one place to the origin itself, this moment becomes 0, only this charge is giving the moment, so it has a net dipole moment. Now, see the next one, the third problem. See, instead of taking the positive charge, here minus and plus is taken. Here minus 2q is kept in the y-axis, here plus q is kept in the negative y-axis. This is the positive side, this is the negative side. What is the distance? The distance of this negative charge is a. Let us take a. This distance is 2a. Now, what is the dipole moment? We are finding what? The dipole moment. The dipole moment for this system of charges or configuration. So, P vector equal to, say, first this charge into the position vector. So, this charge is, first charge is 2 minus 2q, right. The position vector of this charge. The position vector of this charge can be written as A into. Here we have used I cap. Why I cap? Because it is along the x-axis. Now, the charges are in the y-axis. So, the direction you have to specify is j cap minus 2q into a j cap. Then this charge is what? Positive. So, plus q into the distance. What is the distance? Distance is 2a. What is the direction? It is in the negative y direction. So, y direction means, say, minus j cap. So, this plus into minus to minus 2a j cap, 2q j cap minus 2qa j cap. So, this plus into minus becomes minus. Here minus 2aq j cap, here also minus 2qa j cap. So, total value, so minus 4qa j cap. So, this is a dipole moment for this configuration. Now, let us see the fourth example. Here minus 2q is kept along the x-axis, the y-axis plus q and plus q are kept at a distance a. This is a very common example. This is nothing but the water molecule. This is oxygen, this is hydrogen. Oxygen is minus because it is gaining the electron, so it becomes minus. Oxygen is losing the electron, positive charges. The best example is this, minus 2q, the oxygen. Since it is gaining one electron and one electron from the hydrogen, minus 2q. So, the hydrogen becomes positive charge. So, what is the dipole moment for this case? Dipole moment for this case is P vector equal to, yes, minus 2q a into minus I cap, because it is in the negative x direction. Then this is plus q into a j cap. Okay. For this charge, we have to include this charge also, isn't it? So, plus q a into, what about the direction? The direction is minus j cap. The direction is minus j cap. Now, these two are getting cancelling, right? Because it is plus j, this is minus j, cancelling. This minus into minus becomes plus. The dipole moment is 2qa into I cap. So, the net dipole moment for this H2O water molecule is 2qa into I cap. Now, we are going to see the electric field due to the dipole along the axial line. What is the axial line? Suppose if you consider this is a dipole. So minus q placed at A, plus q is placed at B. It is kept at a finite distance. So distance is 2a. This distance is a. This distance is a. Total distance is what? 2a. Okay. This arrangement is known as the dipole. What is the axial line? The line joining plus q and minus q is called, this is known as axial line. Now, what is the electric field at one point? I am assuming the reference point is C, that is the point C is along the axial line. So, now you consider the positive charge. We know the electrical lines always, or electric field is always away from positive. So, this will be acting in this direction, that is E plus vector. E plus vector is the electric field due to the positive charge. Now, this minus q also gives some electric field at this point, say C. The electric field due to the minus charge will be acting along this direction. So, why along this direction? Because towards minus, E minus. So, E plus is acting in this direction, E minus is acting in this direction. What is the net electric field at the point C? We are going to calculate using the mathematical expression. So, here I have drawn E plus as bigger magnitude. E minus is smaller magnitude. Why? Because the charge positive is very nearer to this point. So, electric field is more. We know that when the charge is, when you consider a point very nearer, electric field is more. So, electric field is having the more magnitude. For negative charge is somewhat greater distance, the magnitude is less. So, by combining these two, we are going to find the net or total electric field. Say, O is the midpoint. Let us assume the point C is at a distance R from the center point O. So, draw the diagram. On seeing the diagram in physics, you can see the diagram and you can write the explanation. What is the explanation? Minus q and plus q are placed at A and B, separated by a distance 2a. O is the midpoint of the dipole. C is the point which is at a distance R from the axis, from the center of the dipole on the axial line. That's all. Now, what is E plus? We already seen the formula for electric field is 1 by 4 pi epsilon 0 q by the distance between the reference point and the charge plus q and C. This distance is A, OC distance is R. We have to find this distance. This distance is BC square. Acting along BC square we have to find. What is BC? So, the total distance, if you subtract this A, what you will be getting is minus. So, R minus A whole square. The direction is mentioned. Here BC square acting along BC. The direction, it is acting in this direction. So, this direction, the dipole moment is negative to positive. In this direction, you mention the direction of dipole moment is positive p cap. Likewise, you can write the electric field due to this minus charge. E minus vector equal to 1 by 4 pi epsilon 0 q by. See, you have to include this A. So, total distance plus A. So, R plus A whole square. And the direction is opposite to the dipole moment direction. So, what is mentioned here? Minus p cap. So, next what you have to write is according to superposition principle. If two vectors are acting, what you have to do is you have to add all the vectors. Okay. Here I have written instead of E plus 1 by 4 pi epsilon 0 q by R minus A whole square p cap. Then minus, this minus will come here, minus 1 by 4 pi epsilon 0 q by R plus A whole square p cap. take the common terms outside. 1 by 4 pi epsilon 0 and q is common. So, q by 4 pi epsilon 0 is taken out. So, take LCM r minus a whole square, r plus a whole square. Okay. So, 1 by r minus a whole square minus 1 by r plus a whole square p cap. If you take LCM here, so a plus b into a minus b. So, a square minus b square format. So, r square minus a square whole square. Then you multiply r plus a square here minus r minus a whole square here. Then what is the next step? You expand a plus b whole square formula, r square plus a square plus 2ra. Minus is there, minus is common for all the terms. So, minus r square minus a square plus 2ra. Say this r square minus r square cancels, a square cancels. So, in the numerator, so 2ra plus 2ra, so the total value is 4ra by r square minus a square. Okay. Here some assumption, this is a formula. Suppose if you are assuming this distance is very greater distance, of course the distance between the two charges, that is dipole, is very less. If the distance is more, r is very much greater than a, in this case if you take the squares, r square become more value, a square becomes less value. When you are subtracting, it is, you can omit the a square itself. So, you can omit the a square in comparison with r square. So, r square to the power 2 becomes r power 4. 1 r is cancelling. So, this becomes r power 3. Okay. So, here 4a can be written as 2a into 2. 2a into 2. Why? Because we know whenever you see q and into 2a, that is nothing but what? The dipole moment. So, you include the direction. So, p vector equal to 2qa into the direction is the direction of dipole moment. So, instead of all this, okay, so 2qa into p cap, you can represent by p vector. So, the total electric field formula is 2p vector by 4 pi epsilon 0 r cube. See the direction, this is the magnitude. In which direction it is acting? On seeing the diagram, you can say E plus is a greater magnitude. Two vectors are acting. See, one is a bigger magnitude, smaller magnitude. The resultant vector or the net electric field will be acting in this direction, that is from minus q to plus q. Okay, students. Now we have seen the electric field due to the axial line. Next class we will see the electric field due to the dipole along the equatorial line. See, so far what we have seen is what is dipole, the system of charges, what is the dipole moment formula we have seen. The regarding the dipole we have seen the problems. Then the last one is electric field. We have derived the formula for electric field due to the dipole along the axial lines. See you students in the next class.